Welcome back, my students. This is a lecture where we are going to cover scanning electron microscopy, simply we called SEM, SEM. Okay, this topic is coming under the module 2, and we have the subject code 6805, I think, advanced materials and tools, under that only. Okay, now let us start with small introduction about electron microscope. So nowadays electron microscopes are very popular, not only in research and development, for educational purpose also we are using. And in your school days and normal laboratory, we may have the word microscopes, optical microscope. Okay, these are the scientific instrument we are using. Okay, in optical microscope, that is called light optical microscope also we can call, we are using light rays to capture the microstructure and other related things from metallic non-metallic object. Okay, but they have some limitations. Those limitations we will see in incoming slides. Okay, so to overcome those difficulties, scientists who have developed electron microscopes. Okay, they are so popular in 1930s onwards and etc etc. Okay, so the in optical microscope we can go with 100x, but image should be somewhat blur and very noisy, and the sample should be perfectly flat, and other lot of issues are available to get a higher resolution image in optical microscope. But in scanning electron microscope we can go to 10,000x also. You will get nice images, not a problem. Microstructure, a single grains, etc. You can focus it, and this is applicable for metallic as well as non-metallic. Okay, for non-metallic we have to take some precautions that we will see in upcoming slides, not an issue. Okay, so let us start with the definition of SEM. So electron microscope that produce images of a sample. Sure, it's correct. By scanning over it with a focus of beams of electrons. Yes, absolutely. Because the name itself have the answer, scanning electron microscope. So we are going to use the electrons to scan the surface. Okay, and remember to scan the surface, not the inside. What is inside? Okay, remember, and because this is a small difference between TEM and SEM. Okay, so the incident electrons interact with the electron in the sample. Okay, producing the various signals that can be detected. Sure, because after reaching this sample surface, and it going to diffracted or reflected. Okay, so that signals is going to captured and amplified, and it will go through this CRT monitor where we are going to see their surfaces or structures, etc. So one by one we will see slowly. Okay, so types of electron microscope, there is two types, is basically one for analytical electron microscope, AEM, and another one is scanning electron microscopy. So here I want to tell one more terminology. There is AFM, atomic force microscopy. Do not engage yourself or confuse yourself with AEM with AFM. Only small alphabet is missing or replaced. Okay, that it will be good. So one is the X-ray spectroscopy, energies loss, electron energy loss spectroscopy, electron spectroscopic imaging. That's not a matter, but our focus with the SEM only. So secondary electron imaging, SE, and backscattered electron imaging, BSc, and we will see how we are going to use these two in our imaging processor with respect to scanning electron microscope machines. That upcoming slides coming. Okay, so another types of electron microscopes are TEM, SEM, REM, STM, and low voltage electron microscope. Depending upon the applications we can change this thing. Okay, and the equipment, cost, etc etc. Okay, the difference between SEM and TEM, most of the time you are getting confusion with TEM and SEM. Very first, SEM is bar thick, TEM is for thin. Okay, in transmission electron microscope, transmission means here to there it's going to reach. Okay, so in TEM, this electron beams which are produced can pass through the samples which you are produced. Simply say very thin, and the sample sizes will be very small. And in the exam paper, if there is no hole in the paper, you are taking punching machine, you are making punches, right? So that much size of samples only we need. This whole level samples are need, and sample should be very thin. It should be like it should able to pass the electron from one side to other sides. Otherwise it is very difficult, and sample preparing procedure also very difficult for TEM. That's what it was, higher fees are collected for TEM samples. Normally 7,000 is nominal charge, and 10,000, 12,000 also they are collecting for TEM. For metallic material it's very difficult. SEM it's not like that. Within 1000 rupees you can finish one samples along with EDX also. That means elemental analysis also you can analyze by using the SEM. Okay, these are very basic things, and other things are shown in the place. Okay, TEM shows the samples as a whole. Yes, absolutely, I accept it. And TEM seeks to be see what is the inside or beyond the surface. Yes, absolutely, that's what I'm telling. Scanning electrons are passing through their surfaces. Okay, so these are simple differences between TEM and SEM. Kindly note it down. Now we are coming to the instrument. So scanning electron microscope, we have few parts. First one is the electron gun. Okay, so from that only we are going to start. So let me check. First electron gun, and most probably you should know that electron guns are made by tungsten because they're having the high melting point. Okay, so after that only it is passing through, then it will going through the anode. So beams are collected and it is going to anode. What anode can do? Okay, anode can attract the electrons, right? So the weak electrons which is coming through the electron gun will be attracted by the anode, so that they will not go and disturb the second stage, that is where is the magnetic lens. Okay, so after the anode, just before the anode, you can see it, just before the anodes we have a beam, conical size of beams are coming. After the anode only the beams, electron beams which having the good strength and which is coming through the hole only passing through, and their shapes are oriented. Okay, the parallel shapes are made, that's not a issue. Then next one is the magnetic lens. Okay, so magnetic lens will give the shape. Okay, they're going to change the shape, how much focus we want, those things will be changed. Okay, let me see this diagram. We have a condenser lens instead of magnetic lens, we have condenser lens. That is very nice that we can use. Okay, so first one is the condenser lens. Just like optical microscope, we are using a condenser lens to produce clear and detailed image. Okay, so next option is the condenser lens, which is used to work. It's different than the optical microscope, remember, and don't confuse, similar type but it's a little bit different. Okay, so sometimes if you want you can use magnets, that also you can use. That's what here we have seen the magnetic lens, but here is in condenser lens. Both are same, they both are going to do the same type of work only. So condenser lens focus and control the electron beam. Okay, that's what after the magnetic lens your beams are focused towards a single point, and before, in between anode to magnet, it was parallel. After that it was reducing. Okay, and it was focused towards single direction. You can see the shape how it was different over here and here also. Okay, and so this is very helpful to control the electron beam and ensuring the electrons end up precisely where they need to go. Okay, that's an objective lens. Sometimes here you are using only one magnetic lens, here they are using two condenser lens, so that precisely it can pass through. Okay, and one thing you should know, everything is placed inside the chamber. So next, when we are talking about the chamber, we will get how it's going to looks like. Okay, so signal from the chamber after passing through the objective lens, objective aperture and object, yeah, that we will see, objective aperture and other things we will see, not an issue. And condenser lens we have seen, and okay, so inside the objective lens, so objective lens we are going XY scan coils, where it's going to move, and we're going to check at what directions we are going to focus, or which one we're going to focus. Okay, so let me come to the last one. We have a backscattered electron detector. Okay, if any electrons are getting backscattered, secondary electron detector is nothing but SE. Okay, signals from the samples, simply say it's from the samples. Okay, so any incoming electrons, secondary electrons, backscattered electrons, agar electron, X-rays, cathode, luminous samples, etc. will be there. And the secondary electrons we shortly call SE. Okay, which is generated from the collision between the incoming electrons and the loosely bonded outer electrons. Okay, then later the low energy electrons, okay, which is having 10 to 50 electron watts, only generating these secondary electrons, okay, which is close to the surface escape. Okay, so and another one is the backscattered electrons. Okay, that is in fraction of the incident electron is retarded by the electromagnetic field of the nucleus, and if the scattering angle is greater than 180 degree, you can check, then the electron can escape from the surfaces. Okay, here it is high energy electron. Previous one is very low energy electrons at 50 to 10 to 50 electron volts, but it was high energy electrons. Okay, pure backscattered electrons, then AC electrons are coming and not an issue. Then we are having the detectors. Detectors are very much important. Various type of detectors are available in this same, and but most probably we are using solid state detector, which is coated with aluminum. We are using, not a big matter. Okay, so after the detectors, it will go to the amplifier, because the signal which we received after the reflections, the backscatter electrons are very very small, and it is very difficult to process. So we need amplifier to amplify the signal. Then only we can get the images in the CRT monitors. Okay, for instance, and Everhead Thornley detectors are registered. It's a secondary electrons, and this will give the electrons dislodged from the outer surface of the specimen. These detectors are capable of producing the most detailed images of the object, which is not the surface of the object. Okay, other detectors also you can get, such as backscattered electron detectors and X-ray detectors, also used to get the additional details. Okay, and depending upon your research work, you can use which one you want. Okay, that is the one we are using. Everhead Thornley, the backscatter electron detector is called solid state detector. Okay, most probably we are using. If any other names also coming, don't confuse with that, just simply tell it it's a solid state detector. In the exam also you can use the word solid state detector. Is not a big mistake. Okay, I will not reduce any other marks. And I told you to, we have see the elemental analysis also, that is made from the X-rays, because weak X-rays also produce. We have one X-ray detector on the images, as you can see over here. So that will going to give the elemental analysis. So if you want, you can engage your sample with XRD, otherwise you can engage your sample with SEM. You can see the microstructure, and this one also you can produce this. Okay, now let me check the second one. Here all the equipments are placed, not all the parts are placed, not equipment, all the parts are placed inside the chamber. So how the chamber is going to be? Okay, so in electron beams are passing, there should not be any obstruct. So we are going to remove the air also from the chamber. So we are going to make the vacuum only. Okay, so vacuum chamber is required for TEM, SEM, etc. First you have to open the cupboard, you have to load the sample, then you have to tight it, seal it, then you have to make the vacuum. After that only you can go for analysis. This is also one of the major disadvantages, because we have to wait for 15-20 minutes or sometimes higher than also, depending upon the vacuum creating machines or equipments or pumps capacity. Okay, so without a vacuum, the electron beam generated by the electron gun would encounter constant interference from the air particles in the atmosphere, and you know that electrons are passing through atmosphere, they are producing ionization effect, which also going to spoil your output. Okay, so before reaching the object, their energy will be lost, because they are going to make ionization one by one, so it will lose. Okay, and that's it. So advantage, if you see, let me go to the second one, and you can see some of the fewer for condenser lens, they're using magnetic coil. If you see the magnetic coils, how it was focused and pushed through the objective lens. Okay, then it is a secondary electrons are captured, it's go to amplifier, then it go to display. Okay, so it's going to check. So these are all the parts where we can easily match, which is inside. Okay, so we cannot see it, unlike our biological samples, we cannot cross section and we cannot see this thing and identify. These are all the things are placed inside. Okay, let me check these sample preparations. Okay, so that is a very simple step. I will tell it to you. If there is a conductive samples, metallic samples, nothing to worry. You just prepare the sample for 10 mm length, 10 mm width, a square. Okay, then 10 mm 10 mm thickness, maybe 2-3 mm. Okay, but don't go for maximum thickness. Okay, and you can engage your tensile test fractured portions, corrosion samples, or welded sample, etc., etc. If you want to see the microstructure, first you should do the sample preparations. After the preparations, you have to engage your sample with the machine, so that only you can see the microstructure and other things. If you newly developed any alloy that elemental analysis also you can do by using the XPS model. No, not XPS. That X-ray we are taking, that EDX analysis is possible. That is also elemental analysis, line analysis, point analysis are available. So point is nothing but you can particularly pick one point, again you can check the composition, and the line analysis means one end to another end you can make one line. Through the line you can check what are the things you have. Okay, what are the alloys or things are you have it in the lines. And you can check for area analysis. Area analysis nothing but you can focus on area. Okay, and you can check what are the elements are placed inside that area, not an issue. So coming about the biological samples and non-conductive elements. Okay, in biological samples it is very difficult. Okay, so what we have to do, we have to give the coating, that is called sputtering. So we most probably we are using gold material to give the coating over the biological samples, so that it becomes conductive, so surface will be conductive. So by using that only we are going. Okay, otherwise it is very difficult. And biological samples we have to take 1 or 2 times and trial attempt. You have to check whether it is going to spoil the machine or not, and their capacity only. We are going to change some other scanning electron microscope like low LBEM something we have seen first, right? That also we can and check. So these are the grids. Inside the grids only we are going to place our samples. Okay, so these are all the gold plated things. As you can see, the B is coated with the gold. Okay, then only they are going to analysis under the scanning electron microscope. And these are all the grid. Okay, different grid for holding the samples, and this is the most probably we are using. So at that time we can go for 6-7 samples. Okay, in the grid only we are putting. Sometimes we are being double side selector to stick with this grid so that it will not come down. Okay, while analyzing the things. Okay, so now it's okay. Now let me tell the advantage and applications of SEM. Okay, advantage already told, high resolutions we can go. Okay, so wide range of applications we have. 3-dimensional and topographical images also can be produced, and informations, and like XRD here you can get microstructure directly and surface correctly, and you can get the elementals also operated with the proper training and advantages in the computer technology, which give the images very clear. Okay, and if any surface irregularity is available, that also can be adjusted with the same equipment, not an issue. But in optical microscope is very difficult. Surface should be perfectly flat. Okay, all the samples must be prepared, placed in the vacuum chamber. That's the only thing we have to worry. Otherwise it's okay. But there's some disadvantages. Let us see. Size and cost, because we cannot put bulk size images workpieces inside the machine, and the cost also very high, crores and crores we have to invest, and the maintenance cost is also high. Okay, SEMs are expensive, large, but it's very difficult. Okay, so I told you maintenance also very difficult, and operator skills also needed. Otherwise you cannot get a clear cut images. Okay, so it is limited to solid, inorganic samples and small samples, and for big samples it's very difficult question only. So applications, as I told, all the material science, biological samples, alloy development, etc we can use. Okay, so chemical analysis also we can do. Some have in practical industry and technological applications, maybe for semiconductors and other things also we can use. And if you are made any MIM circuit, you can check what is the dimension and other things. Okay, biological applications, I told you can see the bees over here, and that also we can check. So students, I strongly believe that I have taken this SEM very well, and if anything is needed, something also we can check. And so sample preparation I already told. So another application is not only by giving the coating to the biological samples. In the biological samples we have to go for dehydration, because in all the biological samples, like including plant or species animals, we have some liquid content inside our body, so we have to dehydrate the sample before we going to use. Otherwise what will happen, waters and others may be used as act as a dielectric medium, and they will also spoil. Okay, so that we should take for in addition to the sputtering. Okay, most probably it is gold, sometimes gold, platinum etc we go. Okay, so I strongly believe that I have covered. And still, if something is need to tell means, I will inform you while taking the class. Otherwise, we can close this lecture. And remember, there are few things in the images should be placed. I can see I can give two, three different type of scanning electron microscope images. So, but first you have to put the electron gun, anode, magnetic coils, and scanning coils. Okay, backscatter electron, secondary electron, stages, specimens. This and the detector, monitor, scan generator. Those things should be placed in images. Without this thing, you cannot made the drawing. Okay. Otherwise, I will not give any mark. Okay. Okay. So these are all the things we have discussed with scanning electron microscope, and I strongly believe that I have covered a lot. Then okay, now I am ending my lecture. Okay, okay, students. See you with another lecture. Bye.